Jeez. Alright. So, one valence electron is lithium, has one valence. Fluorine has 7. Lithium wants to lose one electron and transfer it to fluorine. Fluorine wants to gain one electron from lithium. Thus, lithium would have a +1 charge because it's losing an electron. Fluorine would have a -1 charge. And this is Lewis dot. Lewis dot, basically you put the number of valence electron as dots around it. So lithium has 1 valence electron, so you put 1 dot around it. Fluorine has 7, so you put 7 dots around it. Try to spread out the dots. So carbon has 4, so you put 4 dots around it. Don't put all 4 on one side or group them in pairs like this. Spread them out. You can only have at most 2 dots per side. So lithium, now I caught up. Lithium wants to give up an electron. It wants to give it to fluorine. So when it gives it to fluorine, it gains this plus charge, and the fluorine gains, so it gains this plus charge, and fluorine gains this negative charge because it has transferred it over. So only 1 lithium is needed to make fluorine have 8. So if we count the dots around it now, fluorine has 8. So for every element, what we're trying to do is remove all the dots or give 8 dots to it. Does that make sense? We're trying to either, and where's your mask? Go get one.
What was it? 5 minutes tops?
So when we take lithium, and this is the first problem, when we take lithium, it has 1 dot. And chlorine, how many valence electrons does it have? 7. So chlorine is going to want to so we have lithium and chlorine are 2 atoms. Lithium has 1 valence. 1 valence electron, and chlorine has 7 valence electrons. So lithium is going to transfer its 1 electron to chlorine. So it's going to donate or transfer 1 electron. The chlorine is going to accept 1 electron. And the ions produced is lithium +1 and chlorine -1. We usually emit the 1s. And we see this is a 1 ratio. So this produces lithium with no dots around it, and it gets the plus sign, +1. And chlorine that now has 8 dots around it. And has a -1 charge. So what our 2 elements here are calcium and oxygen. So we're adding together calcium and oxygen. How many valence electrons does calcium have?
1, 2, 3, wait. 4.
Does everyone see how to get the number?
2.
It's in this column. So this is your 1A. This is your 2A. Calcium is right here. So it has 2 valence. How many does oxygen have?
6.
So this is 3A, 4A, 5A, 6A. Oxygen has 6. So I'm going to put 2 dots around calcium. And I'm going to put six dots around oxygen. And we notice these 2 gaps right here. So calcium is going to give one electron to this spot, and one electron right here. Yeah, you're supposed to be writing my writing. And this makes, what charge does it have now? So, I should say, is going to transfer or donate. It's going to transfer 2 electrons, while the oxygen is going to receive or accept 2 electrons. So, if it's gaining, if it's losing, if it's transferring 2 electrons, that would make it have what charge? If it's giving up 2 electrons, it would have what charge? Plus 2. And if it's gaining, if it's retrieving, I know it's messy, if it's retrieving 2 electrons, it would get minus 2. It's getting 2 negative charges, so it should have negative 2. So we're removing the 2 dots, making this plus 2. And we're gaining 2 dots around oxygen, making this minus 2. Retrieve. Where up? CA should be plus 2. CA is plus 2. O is negative 2. Alright. For these 2 cases, it's very simple. This is where I'm trying to get at. So, beryllium, we have, this is the important one, number 3. How many valence electrons does beryllium have?
2.
So it has 2 valence electrons. How many does fluorine have?
7.
7 valence electrons. So let's look at the picture. We have beryllium, and it has 2 dots around it. We have a fluorine that is missing a single dot before it can get 8. So it wants to either have 8 or 0. So one of these dots can come over here and fill up this gap. But it still has a dot. What are we going to do with this dot?
Leave it.
We can't leave it. It has to be 0 or 8.
Oh, then it goes to 0.
We can't just magically get rid of it. We have to give it somewhere. So what do you think we should do?
Give it to a different one.
What do you mean by a different one?
Get 2 fluorine.
Get 2 fluorines. We're going to find another fluorine. And we're going to give this electron to this one. Again, we're reacting a bunch of beryllium and fluorine atoms. What this means is that we're going to have 1 beryllium. It has lost its electrons and become a plus 2. And we're going to have 2 fluorines. Each with what charge?
-1.
Negative 1. So we indicate 2 by putting a subscript right here. So we see in the formula when beryllium interacts with fluorine, it becomes BeF2. There are 2 fluorine for every beryllium. So in the previous examples, we had a 1-to-1 ratio. 1 calcium for every 1 oxygen. That's because we had enough electrons and enough holes to fill them. Here, this had 2 electrons and this was only missing 1. So we needed another fluorine to give it to. So the beryllium is going to donate 2 electrons to the pair of fluorine atoms. Each fluorine is going to accept 1 electron each. Beryllium becomes +2. And fluorine becomes -1. You able to work on your test, Tristan? You able to work on your test at the same time? Test is more important. If you need to go in the lab, I'll let you. I don't like the fact it gives you the solution right here. I would have scribbled it off and made y'all write it. As you can see, 2 fluorine is in the equation. So magnesium, it has how many? So we have magnesium and we have sulfur. Magnesium has how many valence? It has 2 valence. It's in 2A group. Sulfur has 6 valence. So magnesium has 2 dots. And sulfur has 6 dots. So one of the electrons can come over here to fill this gap. And one of the electrons can come over here and fill that gap. This would make magnesium have what charge?
+1, +2.
+2. It's losing 2 negative electrons. And sulfur is going to have what charge?
-2.
-2. So this is going to become +2, and this is now going to have 8 dots around it. By the way, you can think of the arrow sign as an equal sign. And there's no plus because we've combined them together. Lewis, this is still a Lewis dot structure right here. If it has a charge, we always put it in brackets and write the charge on the outside. If there is no charge, we don't put brackets around it. So our atoms are potassium and fluorine. How many valence does potassium have? And how many does fluorine? 7. Potassium is sitting here with 1. We're adding with it a fluorine that has 7. This 1 electron can go right here. So we're removing, this should be a K. We're removing that 1 electron. And it's going to get a +1 charge. And we're adding this electron right here, giving it a -1 charge. So it becomes fluorine -1, potassium +1. So it's going to donate an electron to fluorine. And this one is going to accept 1 electron from potassium. And over here, it would be donate 2 electrons to sulfur. And this one's going to accept 2 electrons from magnesium. Everyone good? Alright, I'm going to skip around a little bit. I'm going to look at number 11. I'm pulling out another piece of paper because it's going to get very messy. So we have aluminum plus oxygen. Oh, and this one doesn't have any solutions now. Now we're going to actually figure out what this makes. So, how many valence electrons? Let me write it over here.
3. 3 and 5.
Alright, so aluminum and oxygen. Aluminum has how many valence?
3.
And oxygen has 6. Alright. So aluminum has 3 dots. And oxygen
6.
has 6. Alright, so how can we do this? I could take one of these dots and put it right here, right?
Right.
I could take this dot and put it right here, right? And this oxygen would be happy. It now has 8 dots whenever I transfer it up. But aluminum has 1 dot. It really doesn't want that 1 dot. So what does it need to do?
Give it to one that needs 1 dot.
So it's going to find another oxygen. And remember, oxygen has how many dots around it?
6.
And it's going to give that one 1 electron. Oh, we got a problem. This oxygen still needs 1 more electron. So what's it going to do? It's going to find another aluminum that has 3 around it. And it's going to grab 1 from it. Oops, we got a problem. Aluminum has 2 dots around it.
I know what you do.
What do we do?
You find another oxygen and shoot them over there.
Oh yes, that's exactly what we do.
Dang, you're pretty smart.
So we're going to take this and put it over here. And put it right there. Is all of them happy?
Yes.
The aluminum all have no dots around it. We've given them away. All the oxygens have 8 dots around them. So how many aluminum do we have?
2.
How many oxygen do we have?
3.
And what would the charge on the aluminums be?
Minus 3.
Plus 3.
Yeah, that's what that.
And how many does the oxygen have?
Plus minus 3. Minus 2.
Minus 2.
Goodness. That was wrong.
So what would be the formula? Al2O3. So, how would you word this? Each aluminum will donate 2 electrons to 1 oxygen and 1 electron to another. Each oxygen accepts 2 electrons. So the charge of aluminum is going to be plus 3 because each of them are losing 3 electrons. And each oxygen is gaining 2 electrons. The electrons are negative, so it becomes negative 2. What's the overall charge? So we have we have two of these, and we have three of these.
They're the same.
So that'd be 2 times plus 3, and we're adding to it 3 negative 2's. What is plus 3 times 2?
6.
Plus 6. What is 3 times negative 2?
6. Negative 6.
So 6 plus negative 6. So 6 minus 6 is 0. Compounds have no charge. So when aluminum and oxygen interact, it makes Al2O3. It does not make ALO. That's wrong. It doesn't make Al2O. That's wrong. The correct formula for aluminum oxide is Al2O3. So just because I say the word aluminum oxide doesn't mean it's ALO. It's Al2O3. These charges all have to counteract and balance each other out. Make sense? You can already see here the chlorine is going to be triple. So we have an aluminum that has 3 dots around it. Because aluminum has 3 valence electrons. Chlorine has how many?
7.
So that means each chlorine has 1 missing spot on it. So this aluminum can only donate 1 to it, but it has 2 left over. So we need another chlorine atom for it to come over here and donate. And we need a third for it to come over here and donate right here. So when aluminum has no more electrons surrounding it on its valence, it gets a plus 3 charge. Chlorine, when it gets all 8 around it, it's a what charge?
-1.
-1, and there are 3 chlorine. So the aluminum will donate 1 electron to each of the 3 chlorine. And a chlorine will accept 1 electron. So each chlorine will accept 1 electron from aluminum. So sodium versus oxygen. Sodium has how many valence?
1.
1 valence. Oxygen has how many?
6.
So this has 1. Whereas oxygen has 6. So when it gives this up to this spot, oxygen is still missing 1 right here. So we need another sodium to fill that hole. So we're going to end up with 2 sodium atoms. They get a plus 1 charge for every 1 oxygen. And the oxygen will get a negative 2 charge because it's gaining 2 electrons. Try working with 8.
What?
Mm-hmm. Or do not try. Do.
Oh,
Or do not.
good.
So this next unit is going to be slightly harder. It's very important that you get this down. Yeah. Once you solve this. Are you almost finished with your test? Should be focusing on the test and not what we're doing. This is notes, what we're doing right now.
The test is more important.
The test is more important than notes. When we work on something together, it's almost never for a grade.
So this is just notes.
Yes. Which I want you to solve right now.
Goodness, I'm so smart.
Don't say it, but Jacob, you got the answer? Anyone else?
I mean, at least I think I do.
You forgot to actually write the final answer.
That was close, right?
No, you're right.
Oh, I am? Okay.
You're not close. I'm actually only looking for that one number next to the formula.
You're right.
Oh, what?
Oh, right. Excuse me, Mr. West.
Oh, yeah. I'm fine. I was looking not what I found.
You get it?
Scared me so you would- I'm glad I heard a knife.
All right. So we have lithium. Lithium has how many valence?
One.
So I'm going to put one dot beside it. Nitrogen has how many?
5, 6.
So I'm going to come over here and put 5 around it. So this one is going to come over here and fill this spot. But it still has 2 empty spots right here and here. So I need another lithium to come over here and donate it right there. And I still got one more spot. So I need another lithium to come over here and do that. So now the lithiums all have no dots. And if you take one lithium, remove a dot, that gives it a +1 charge. We have 3 lithium in total. And the nitrogen has gained 3 more dot. So it's originally like this, and it's coming over here. This lithium is giving it that dot. This lithium is coming over here and putting that dot. And this one's coming over here and putting that one. So it's getting 3 electrons. So it's going to get a -3 charge. And there's only one of them. Again, we usually omit ones. So the lithium is going to get a +1 charge. The nitrogen, a -3 charge. So our formula is Li3N.
Alright, so what was it again? Wow. Sentence back on. Is it +1?
I've never taught this method, but I feel like you guys would get it visually better than the crisscross method.
I agree. It's not even
I just use my
I'll actually show you all the crisscross method.
No. That's not very sure.
So lithium is +1. Nitrogen is -3, right?
Yes.
So if I put Li next to each other, I'm going to That becomes a 1. I'm going to cross a 3, and we usually omit ones. So Li3N. The reason why I don't show you guys the crisscross method is let's do one we've already done. Let's do crisscross method of calcium, which is 2+, and oxygen, which is 2-. So I write it down. I cross, and I get Ca2O2. What was the real formula? With imaginary ones next to it. That's because you have to divide by 2 if they're all even. Which is why I thought graphically it was better, as I don't want to see any of this as kind of wrong. Having it visually where you match up the dots, you see this is a 1-to-1 ratio.
I don't like the crisscross method.
Yeah, that's the reason why I didn't. Another way of looking at it is we need these two numbers to add to 0. So I would do one of these for one of these. In order for these to add to 0, I need 3 of these. 3 + 1 charges to counteract the -3 charge. By the way, I'm thinking the test is going to have a lot of this. Li plus N. The answer choice A will be Lin. The answer choice B will be Li2N. The answer choice C will be Li3N. And the answer choice D will be Li3N2.
Gotta be in my eye.
So you would know C is the correct answer.
You taking the test tomorrow?
Oh no.
Huh?
Oh no.
Is this all the testing though? I feel
Maybe.
I think we got it.
That's very difficult.
Okay, too hard. Talk about what's set.
All right. One more. Yes. Bell's gonna ring in like 3 minutes. 3 or 4. So magnesium has how many?
2.
Fluorine has
7.
So I'm going to put 2 dots around magnesium. Fluorine, I will put 7. So fluorine is missing one right here, so we can fill that. But magnesium still has 1, so that means it can still give an electron to another fluorine atom. So we can come over here and add it right there to that missing void. Magnesium is losing 2 dots. making it +2. Looking at just one fluorine is gaining a negative electron. So -1. And there are 2 fluorine, and there's 1 magnesium, but we don't put 1s. So our formula right here is MgF2. Really, you shouldn't put the 1 here, but I will allow this. Do not, however, write Mg1F2. Don't put the 1 on it. It's not H2O1. We omit the 1s. Another thing is, this is correct for water. Water is actually H4O2. But what's wrong with that? Why don't we say water is H4O2? That's the correct formula for water. It's not the formula unit. Formula unit is the lowest possible ratio. Are these numbers even?
Yeah.
You can divide by 2. What is 4 divided by 2? 2. What is 2 divided by 2? 1. But then we omit 1.
Can you take this home?
Yeah. We'll continue it tomorrow. Don't lose it. I might actually accept it for homework, and I will take into consideration you were taking a test and they're taking a test.
Get your phone. Me? Yeah.
Michael, you did that yesterday.
Do you need something from the front page, Tristan? KP, you can do that outside of class. Keep your mask on.
That's like super.
Oh, that's
Yeah. I was playing with it, you know, and it just went in my eye.
And that made you cry?
Yeah.
Stabbing something into your eyeball makes you cry?
Like I snapped out my headphones because I got mad. Yeah, so they're so that was like
Can you turn over to the back? She's copying it on the front.
I'm almost done.